Today's objective is I can find the degrees in a circle by using the benchmark angles. First up, let's take a look at our vocab. Some of these vocab words are review and some of these are new. First up, we've got benchmark angle. A benchmark angle is a common angle that you can judge other angles against. So these are going to be those angles that we already have memorized. Like when we see that perfect square corner, we automatically know it's 90-degree angle, right? A right angle. When we see that perfect straight line, we already know a straight angle is 180 degrees. So we've spent a lot of time looking at these first three benchmark angles. Well, today and for the rest of this week, our focus is going to be on circles. The angle in a circle measures 360 degrees. So again, when we're talking about benchmark angles, we're talking about those angles that are very familiar to us. We have them memorized and they're at the top of our mind when we're thinking about angles. Next up, let's look at angles. Angles are the area between where two lines meet. So when we're looking at these examples, we can draw an arc to show that these are angles. The arcs show us the area between our two lines. Next up, let's look at circles. We haven't talked much about circles, but we have done a lot of work with circles when we were talking about symmetry. And we learned in symmetry that circles have an infinite amount of lines of symmetry. That means when we found our center point, we could fold that circle in half as many times as we could and we would find symmetry. Well, when we are talking about circles in angles and in rotation, we can look at circles in a different way. Again, we can draw that center point and find the angle inside. So we can draw our arc all the way around, just like we would draw an arc in any other angle. All right, next up, let's look at rotation. So rotation is turning around an axis or center. So the way that we're going to look at rotation today is we're going to look at a circle and we're going to rotate around that circle. So when we're rotating, we're turning around that center point. Next up, let's look at degrees. Degrees are a measure for angles. So we measure angles using degrees. The way that we measure angles is using a protractor. So a protractor, that's that tool that looks just like this, and we use it to measure angles. So in 4th grade, we learned how to use a protractor to measure angles, but we also learned these benchmark angles so that we don't need a protractor and so that we're better at estimating angles. Next up, we have right angle. A right angle is an angle that measures exactly 90 degrees, and we refer to it as our perfect square corner. So again, we don't need a protractor to measure this angle because we've memorized our benchmark angles. So next up, we've got an acute angle. An acute angle is an angle that measures less than 90 degrees. So anything smaller than that perfect square corner is acute. We've also got obtuse angles. Obtuse angles are angles that measure more than 90 degrees. And lastly, we have straight angle. A straight angle is the measure of a perfect straight line. So from here all the way to here, 180 degrees. So take a look at this benchmark angles anchor chart. This is an anchor chart that we made together. So we started off with a full circle, 360 degrees. We cut it in half. That got us 180 degrees straight angle. We cut that half in half again to get a 90-degree angle. We cut our 90-degree angle in half to get our 45-degree angle. And then we took 3 of our 45-degree angles to create a 135-degree angle. Or we could also say that's a 90-degree angle plus a 45-degree angle. So again, this is something that we made together. I just wanted to remind you that we already know a lot about angles. So next up, we don't have a problem to solve. We're just going to take a look at circles, degrees, and rotation. These are 3 of our vocab words that we're going to be using in the next week. So the first thing I'm going to do is draw a center point in my circle. Then I'm going to draw one line going all the way to the edge. Next, we're going to do a full rotation around the circle. So this is one rotation, and we have 360 degrees. So when I think of a full 360-degree rotation, I'm thinking as if I was standing up and I jump and do one full spin. Now let's take a look at a different benchmark angle. So first we started with a full circle, right? We always draw our center point and draw a line out. So now we're going to start at the same point but this time we're going to stop halfway through. So this is one rotation, and I know that there are 180 degrees in a straight line or a straight angle. We can prove this by making a second rotation. So this is rotation 2, also 180 degrees. And when we add 180 degrees plus 180 degrees, 0 plus 0 is 0, 8 plus 8 is 16, 1 plus 1 plus 1 is 3, we get 360 degrees. And this makes sense because we started with a full circle. So if my first rotation was 180 degrees, and on my second rotation, I rotate another 180 degrees, we get to a full circle, or 360 degrees. So it takes 2 rotations of 180 degrees to complete or to rotate a full circle. Next up, we're going to look at rotations of 90 degrees. So again, I always start with my center point. I'll draw a line out to show where I start. And our first rotation is going to be 90 degrees. So let's rotate and I'm going to stop right there. So this is a 90-degree rotation, a perfect square corner. So we're going to keep going and see how many rotations of 90 degrees it takes for us to complete a full circle. So let's move on to our second rotation. We're going to stop where we left off and rotate another 90 degrees. So we were already at 90 degrees. We rotated another 90 degrees. So we can add 90 plus 90 to figure out exactly where we are in our circle. 9 plus 9 is 18, 180 degrees. Oh, well, that makes sense because this looks like a perfect straight line, and our benchmark angle is 180 degrees, right? So that makes sense. Let's keep going because we are not all the way back at our starting point. We have not reached 360 degrees yet. So we're going to rotate another 90 degrees, and then we're going to stop. So we've got our perfect square corner here. This is our third rotation. So we were at 180 degrees, and now we're just going to add on another 90 degrees. So I've got 180 plus 90 degrees, 0, 17, 2. So now we're at 270 degrees. So our third rotation of 90 degrees gets us to 270 degrees. We're still not quite at our full circle, so we're going to keep going. So we rotate another 90 degrees, and we are back at our starting point. This is our fourth rotation. So let's quick add. We were at 270 degrees. We added another 90 degrees. 0 plus 0, 7 plus 9, and 2 plus 1. That gets us to 360 degrees, or a full circle, a full rotation. So when we used our benchmark angle of 90 degrees, our perfect square corner, our perfect right angle, we rotated 4 times. Now we could keep rotating and keep adding on, but today we're only looking at that perfect circle, that 360 degrees. So one thing that I notice is when we split a circle into 4 pieces, we're splitting our circle into 90-degree angle pieces. The next benchmark angle that we're going to take a look at is our acute angle, our 45-degree angle. So let's start with our center point. So we know that when we fold our circle in half, we got 2 180-degree angles, 2 straight angles. Then when we split each of those in half, we got 90-degree angles, right? 1, 2, 3, 4 90-degree angles. Well, when we split our 90-degree angle in half, we get 2 45-degree angles. And we could prove that by adding 45 plus 45 is 90 degrees. So 2 45-degree angles makes up a right angle. So we can go ahead and split each of our 90-degree angles in half again. Now we're going to continue our rotation same way that we did before. So let's start with our first rotation of 45 degrees. This is our starting point. We rotate, stop here, and we're at 45 degrees. Next up, our second rotation. We're rotating another 45 degrees, and we already added 45 to 45 to get 90 degrees. Moving on to our third rotation. So we rotate another 45 degrees. So we can add 90 plus 45 to find our next stop. 0 plus 5, 9 plus 4, 135 degrees. Moving on to our fourth rotation. So we keep going around this circle, another 45 degrees. So I take 135 degrees, add on another 45 degrees. 5 plus 5 is 10. 3 plus 4 is 7, plus 1 is 8. And bring down my 180 degrees. And this makes sense, right? Because we are at a straight line now. And we already know that a straight line is 180 degrees. All right, so we're going to keep going. We are on our fifth rotation. So we last stopped at 180 degrees. We're adding on another 45. Now we're at 225 degrees. Keep rotating. We are on our sixth rotation. So I'm adding 45 onto 225 degrees. So now we're at 270 degrees. Our seventh rotation, we're adding 45 onto 270 degrees. To get 315 degrees. Now we're at our very last rotation of 45, our eighth rotation. So we're taking 315 and adding 45 degrees. To get to 360 degrees. And this makes sense because we know a full circle measures 360 degrees. So it took us 8 rotations of 45 degrees to complete a full circle. And on our way, we crossed a few other benchmarks, like 90 degrees and 180 degrees. So to conclude our lesson, we took a circle that we know measures a full 360 degrees, and we split it up based on the benchmark angles that we already know. 360 degrees, our full circle. When we split that in half, we had 180 degrees in each half. Then we split that in half again, or our circle, into fourths, and we got 4 90-degree angles. We split that up again for our 45-degree angles. And those are just a few easy ways to split up our circle. Now, you could split up 360 degrees by however many degree rotations you need. For example, we could do 10-degree rotations or even 1-degree rotations. We also showed our rotations 2 different ways. We used pictures, right? We used our circle, split it up, and showed each rotation just like this. And then we also used a table. So a table was another really great way to organize our work. And in our table, we included the rotation and the degrees. So both of these ways are really effective strategies for when we're looking at degrees and rotation. Now in our next video, you're going to learn how to use all of these benchmark angles and these tables and degrees and rotation to answer questions.